Welcome to AI Frontiers. Today's episode is titled Fairness, Factuality, and Frontiers in Computational Linguistics, Exploring Language, Bias, and AI Research. We'll journey through 64 cutting-edge papers with a special focus on fairness, factuality, and language diversity. Today's highlight is the paper of the day by Muniz and colleagues examining multilingual bias. This episode offers insights at the intersection of AI, society, and the future of language technology. Consider this. When an advanced AI is prompted in Turkish versus English, its answers may shift, sometimes subtly, sometimes more overtly, toward Turkish perspectives. This is not a random error, but a reflection of how language can shape machine reasoning and cultural assumptions. Just as two people from different backgrounds bring their own worldviews, AI's responses are influenced by the language used. As these systems increasingly inform real-life decisions, it becomes critical to understand the hidden power of language in shaping AI wisdom. Computational linguistics is where language and technology converge. This field shapes how machines understand, translate, and engage in conversation, driving major advances in accessibility and global communication. Yet, challenges persist. Fairness, bias, and inclusivity must be addressed for AI to serve diverse populations equitably. Today's exploration centers on the pivotal research shaping the future of language technology and its societal impact. Imagine computational linguistics as teaching a computer to be not just a translator, but a master linguist capable of nuanced conversation. It's akin to training a dog to not only fetch the newspaper, but to read and discuss its contents. This field spans speech recognition, translation, and the detection of subtle meaning, raising the question, can computers truly participate in our global conversation? As language is the connective tissue of society, AI has the potential to either bridge or widen divides. A key theme in recent research is multilingual and low-resource language processing. Most AI systems are developed for English, with limited support for thousands of other languages. Initiatives like the MultiScript30k dataset are expanding AI's capabilities, while algorithms such as XDoGE enhance performance for Basque, Galician, and more. The metaphor often used is that of a dinner party. For years, only a few linguistic guests were invited. Now, the table is set for all cultures, with multilingual datasets driving fairer and more inclusive AI. Another significant area is the evaluation of factuality, bias, and fairness in language models. Tools like the FACTS Leaderboard assess how accurately AIs present factual information. The FIBER dataset, introduced by Muniz and colleagues, reveals how prompt language can produce bias, akin to a referee subconsciously favoring the home team. The main challenge is achieving fairness and consistency across languages. This is quantified through the concept of factual inference bias, which measures the extent to which language skews AI outputs. Explainability and evaluation are vital themes in computational linguistics research. The interpreter library, for example, functions as X-ray glasses, providing transparency for AI decisions. New benchmarks are emerging for complex tasks such as mental health counseling and hate speech detection. This process is likened to a detective using a magnifying glass to decode AI reasoning. Such tools are essential for building trust and enabling responsible deployment of language technologies. Recent research offers illustrative stories from the frontiers of computational linguistics. Muniz et al. Demonstrated that Turkish prompts lead to a pronounced Turkish entity bias in AI outputs. Fine-tuning models can result in unexpected, historically anchored generalizations. The intern S1MO agent achieved performance comparable to human silver medalists on NATH Olympiad tasks, showcasing advanced long-horizon reasoning. Alsam et al. Revealed that continual learning can help preserve AI safety alignment. In specialized domains, retrieval-augmented models such as MedBioRag excel in medicine and biology, producing more accurate and context-aware answers. The highlighted paper of the day is FIBER, introduced by Muniz et al. This benchmark addresses the lack of rigorous, multilingual AI evaluation tools. FIBER investigates whether language models display bias according to the language in which they are prompted. The dataset covers English, Italian, and Turkish, and encompasses a range of factual tasks. The central motivation is to create a more equitable and inclusive landscape for AI development. FIBER's methodology involves tasks such as sentence completion, question answering, and object counting. It assesses both accuracy and a metric called the Factual Inference Bias Score. Leading language models, including Llama 3.1 to 8b and Qwen.5 to 7b, are put to the test. Results show that prompt language significantly influences outputs, aligning responses with corresponding cultures. This bias is most pronounced for Turkish prompts and in multi-entity factual questions. The impact of FIBER is substantial. It exposes hidden biases in leading language models, showing that English primes typically yield the most accurate and balanced responses, while significant performance gaps persist for other languages. FIBER calls on the research community to advance the development of inclusive, language-agnostic AI models. It also signals the need for improved datasets, evaluation metrics, and fairness standards, setting a new benchmark for multilingual AI systems. Looking ahead, the future of computational linguistics is envisioned as weaving a vibrant tapestry of languages and modalities. Advances may emerge from diverse voices around the globe, not just established tech centers. However, challenges remain, ensuring high-quality datasets, maintaining safety, and respecting cultural sensitivities. The field is shifting from building monolithic systems to nurturing a dynamic ecosystem. Next steps include developing inclusive datasets, implementing continual learning, and advancing explainability. In summary, computational linguistics now stands at the center of AI's global evolution. Research by Muniz et al., Alsum et al., and others directly addresses issues of fairness, trust, and inclusion. Significant progress has been made in multilingual, explainable, and domain-specific AI. Nonetheless, important gaps remain. Engagement and inquiry from the broader community are essential. Participation in the evolving conversation is encouraged, as the future of AI is shaped collaboratively. This synthesis was created using the GPT model from OpenAI, with TTS synthesis provided by OpenAI's text-to-speech tools and image generation supported by Google tools. Every segment of content was reviewed by a human expert to ensure technical and factual accuracy. Nonetheless, possible oversights should be acknowledged, and listeners are encouraged to consult the full list of 64 cited papers for comprehensive information. Love in-depth explorations of AI and language? Subscribe to AI Frontiers for more research breakdowns, notifications about new episodes, and expert interviews. Join a community of curious minds dedicated to shaping the future of AI. Channel AI Frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.